Hi guys, I trust that you're feeling well and lovely. Welcome to this video on inverse functions, and in this video we'll basically be having a look at how to find inverses of any given function or any type of relationship. So we'll have a look at exactly what inverse relations are, we'll have a look at how to find inverses, and then we'll also have a look at the concept of logarithms. So without any further ado, let's get into it. So when discussing the topic of functions, when we are speaking about the inverse, we're referring to the swapping of the domain and range of a function. So the domain becomes the range and the range becomes the domain. What are we saying? We're saying that the x and the y intercepts of a relation and its inverse will interchange. So the x-intercept of a function or relation becomes the y-intercept of the inverse. And the y-intercept of a function becomes the x-intercept of the inverse. The horizontal and the vertical asymptotes also exchange in the case of a hyperbola, an exponential function. The x and y coordinates of any points on the graph exchange. So for instance, when we're looking at a parabola has a turning point at minus p and q. So when we sketch the inverse of, or when we find the inverse of that parabola, the turning point will now be on the point q and negative p. So what did we do there? We just swap the x and y values. So in your exam, you will always be asked, or you will be required to find the inverse of a relation or a function, and that's what this video is all about. So how do we find inverses? The first thing we need to make sure of is that the equation starts with y is equals to. This means if we have any form of function notation, for example, if we have f of x or g of x or h of x, whatever the case might be, as long as we've got something of x, we need to remove that something of x and replace it with y. So the equation must read y is equals to something. Next, we have to swap x and y. Lastly, what we need to do is we need to solve for y in terms of x. Now let's have a look at some examples on how we would do this. So this question says we need to find the inverses of the following equations. So we start off with 3x minus 1, y equals to 3x minus 1. Let's go to a writing pad and let's have a look at how we would do this. So our graph is, or our equation is y is equals to 3x minus 1. Now, if we can go back to our set of instructions, we said that we need to make sure the equation is in the form y is equals to something. Our equation starts with y is equals to, we're good to go. The next step says we need to swap x and y. So, let's go back to our writing pad. Now, swapping x and y is simple. Where there's y, we replace it with x. Then we put y where there was x and then minus 1. Now the next step is we need to solve for y. So I'm going to start off by taking the negative 1 to the other side, and I will get x plus 1 is equals to 3y. Lastly, I will divide both sides by 3, and then I will get y is equals to x plus 1 divided by 3. How I could write this another way is I could say y is equals to x over 3 plus 1 over 3. This is if I write each of the terms in the numerator with its own denominator. Wonderful. There we are. It's as simple as that. Now let's move on to the next question. We have another equation here. F of x equals 4 over 3x plus 5. So let's go to our writing pad and let's have a look at finding the inverse of this. So we have f of x is equals to 4 over 3x plus 5. Now we said we need to make sure our equation starts with y is equals to. Since we have f of x here, let's replace that with y is equals to. Then this is 4 over 3x plus 5. Next, we need to swap x and y. So x is equals to 4 over 3y plus 5. Now the next step is we need to solve for y. So first of all, let's take the 5 to the other side. X minus 5 is equals to 4 over 3y. What I'm going to do then is I'm going to multiply every term by 3 over 4. So multiply every term by 3 over 4. This is to make sure that the 3 cancels the 3, the 4 cancels the 4, and we only remain with y. So now we're going to have 3 over 4x if I multiply in the 3 over 4 minus 15 over 4, and this gives us y. So I could say y is equals to 3 over 4x minus 15 over 4. There we are. Wonderful. If you want to put both of the numerators with the same denominator, you can do so. You could say y is equals to 3x minus 15 over 4. This still gives us the same answer. I hope you guys are finding this interesting, and I hope that you're enjoying and learning something from it. If you are, please don't forget to subscribe and click on the bell icon so that every time when we upload new videos, you get a notification. Most importantly, please share this video with others so that they can all benefit from the knowledge that we are receiving here. Alright, let's move on to the next question. So g of x equals 9x squared. Let's have a look at this. So we've got g of x is equals to 9x squared. The first thing we need to do is where we see g of x, we need to replace it with y. So y is equals to 9x squared. The next step is I need to swap x and y. X is equals to 9y squared. Next, I can divide both sides by 9 so that I make sure that the coefficient of y squared is 1. So this is going to be y squared and this is x over 9. Because I'm looking for y, I need to find the square root here and I need to find the square root there. I'm going to get y is equals to plus or minus, please take note of this, the square root of x over 9. We can write this as plus or minus the square root of x divided by the square root of 9. Now, because 9 is a perfect square, we could say this is the square root of x over the square root of 9 is 3. And there we are. We are done. We have written the inverse of this function. Wonderful. Let's move to the next section. The last question we have is y minus x squared equals to 0. Alright, let's go down for some room. We are looking at y minus x squared is equals to 0. Now we said that we need to start off with our equation beginning in the form y is equals to. This is not the case here. So what I need to do is I need to take x squared to the other side. So I've got y is equals to positive x squared. The next step is I need to swap x and y. So x is equals to y squared. Lastly, because I'm looking for y, I need to find the square root on both sides. Y is going to give me, as we saw in the previous example, plus or minus. Whenever there's a square root, do not forget the plus or minus. So the inverse of this function, y is equals to plus or minus the square root of x. Wonderful. We are done. Life is great. Alright, now let's talk about logarithms. Notice something in these examples. The first two are a straight line. The last two are a parabola. Now the question might be, if we have an exponential equation, like in this form, y is equals to a to the power x. Let's find the inverse of this. We said the first thing we need to do is, we need to swap x and y. We end up with x is equals to a to the power y. Now the question is, how do we get the equation in the form y is equals to something? How do we take the exponent of y and bring it on the other side? Well, this is where we need to use logarithms to find the inverse of an exponential graph. Let's look at this. So the definition of a logarithm, think of it this way. The logarithm is used to find an unknown exponent. So you could say the logarithm, we use it to solve for x or y if x or y is an exponent. Now, if x is equals to a to the power y, as we saw in the previous slide, then it basically means that y is going to be the log of x base a. So in case you've been wondering what that log button on your calculator is, now you know. It is used to find the inverse of an exponential function. It is used to find an unknown exponent. So as I've mentioned, the logarithm is used to find the inverse of an exponential graph. We use logarithms to find unknown exponents in the case that we cannot express the equations with the same basis. Now in the next video, we'll have a look at how to actually find the inverse, how to find exponents, unknown exponents if the bases are not the same. Right, let's look at the first example. So we're supposed to find the inverse of f of x equals 2 to the x. Okay, let's go to our writing pad and let's open a new sheet of paper. And we have here f of x is equals to 2 to the power x. Now, as we said, in our process of finding the inverse, we first need to make sure that our equation is in the form y is equals to 2 to the power x. Wonderful. Next step is we need to swap x and y. So x is equals to 2 to the power y. We are solving for an exponent which is unknown. So I could say y is equals to, because we are finding an unknown exponent, we introduce the logs. Now, let's quickly think about this. What is our base in the case of our original expression? The base is 2. Because the base of the original expression is 2, it means the base of the logarithm is 2 as well. There we are. Wonderful. Let's look at the next question. So for the next question, we've got g of x is equals to 1 over 3 all to the power x. Let's look at this one. I'll do it on the side. So g of x is equals to 1 over 3 all to the power x. The first thing we need to do is we need to write our equation in the form y is equals to, this is 1 over 3 to the power x. Next step is we need to swap x and y. X is equals to 1 over 3 to the power y. We are solving for an unknown exponent. So y is going to be equals to, we introduce logarithms. Once again, the base in our original expression is a third, so the base in our logarithm has to be a third. There we are. Life is great. Alright, let's look at the last question. So this one is a bit interesting. We've got y equals 3 over 2 all to the power x minus 1. Let's look at it. So y is equals to 3 over 2 all to the power x minus 1. So we said the first thing we need to do is to write our expression in the form y is equals to. That's good. We have it sorted here. The next step is we need to swap x and y. So x is equals to 3 over 2 to the power y minus 1. We are looking for an exponent. The exponent is unknown. So let's introduce logarithms. In this case, I'm going to put y minus 1, because that's our exponent, is equals to the log of, we've got x, the base is 3 over 2. But now our equation must be y is equals to, not y minus something. So what I can then do is take the negative 1 to the other side, and I will remain with y is equals to the log of x, base 3 over 2, plus 1. And there we have it. This has been a short video on finding inverses of graphs and functions. I hope that you guys enjoyed it and found it useful. If you did, please give us a like. Please subscribe to the channel. Click on the bell icon so that you can never miss an update every time when we upload new content. If you found this useful, please do share the video with others so that everybody can benefit from the knowledge that we're learning. Until then, have a wonderful day. I shall see you guys in the next one. Ciao.